One of the things I said earlier on in the course is that almost everything is an object in .NET and in C#. And the way that that works is that at the base level of the .NET library is a base type called system.object. All of the other types that we talked about so far, such as ints and doubles and characters and bytes and so on, all of these are primitive types, but C# actually derives all of these base primitive types from system.object. What's interesting about this is that even though the int data type is built into .NET and C#, int actually maps to a system.int32. Int is just a shorthand way of saying use the class system.int32. The same thing goes for char. A char data type is actually a system.char object. Same thing with strings. Strings are system.string objects. These all derive from system.object. And the same is true for all the other objects that you see listed here and all the primitive data types. Dates, bytes, doubles, all of those are actually objects. They derive from system.object. So why is this important? Well, it lets you do some pretty neat things. If I were to declare a variable int I is equal to 0, I could do the same thing by saying int I equals new int. Other languages don't let you do this because they don't understand it, but in C# and .NET, because pretty much everything is an object, you can do this. These are functionally equivalent to each other. Declaring the variable as an integer and initializing it to 0 and saying new is pretty much the same thing. It also means that the built-in objects have some pretty cool features. So for example, this integer is really an object and it has functions that I can call on it. So I could do things like i.getType, and that would return system.int32 because that's the kind of object that it is. I could say i.toString, and that would return a string. Now remember, I'm doing all this on a basic integer. I could do things like i.equals and give it an argument, and that returns whether two objects are equal. So once you get around the idea that everything pretty much in .NET and C# is an object, it gives you a certain amount of freedom in your programs and some really great functionality that other languages don't provide. Let's take a look at an example. Let's return to our old friend, the is operator. Now, I briefly talked about the is operator earlier on in the course, but now let's take a look at how you might use it. Suppose I had a function that took an object as an argument. And again, remember here that that word object is really an alias. It's a shorthand way of saying system.object. So here I have a function that's taking an object as an argument, and it returns an integer data type. Inside this function, I would be able to do things like say, hey, if the argument that I'm being given is an int, then I can convert that object to an integer and then operate on the argument as if it were an integer. Or I could say, hey, if the object is a string, then convert the object to a string and then operate on it as if it were a string. This gives me a lot of flexibility in the way that I write my code. I can write some C# code that's very flexible, takes different kinds of arguments in one large container, and then convert between them as I need them. So what's so great about this? Well, first, the fact that pretty much everything is an object provides a unified way of working with all the variable types. You don't have to treat primitive types one way and objects another way like you do in other languages. Basic variable types in C# have some pretty cool automatic features built in, and we'll see more of this as we work with each one of the other data types in depth. All the C# types can be converted to and from objects. So they can be passed to functions that take objects as parameters, as you saw earlier. So now you can write code that's very flexible. You can write functions that take objects and take variables of different types and work on them as if they were each one of their own types. So for example, I could write a function that takes an object or a series of objects, pass them all kinds of variables like strings and integers and doubles and floats, find out what kinds they are, and then work on them as I would an ordinary variable of that type. And we'll see examples of this as we move through the course.